Okay, so 1.3 is transformations of functions, and then they just tell you a little bit more on inverses of functions. Now, transformations of functions you guys did in secondary math 3. Does anyone just remember, not any of the actual math, but do you guys remember like doing transformations at some point in the year? Yes or no? Okay, cool. You don't need to remember the details. We're reviewing that right now. So everybody, let's talk about this. In 1010, they just have you write it in a way that you really didn't write it in secondary 3. So it's learning how to write something. And yes, it takes some memorization. So we're going to start out with a parent function, and we're going to call our parent function f of x. This is the non-shifted function. We're then going to take that function and we're going to shift it in some direction. Left and right, up and down. We might reflect it. We might stretch it. There's lots of different shifts. So now we're going to explore what the different shifts looks like. So now you're going to write down up and down in your notes. Shifts up and down are considered vertical shifts. So they might say shift your graph vertically up 3 units. So that's why they could use the word vertical. Now, I would make a note of it. Whatever I have in the highlighted, it's because it's important. Now, a shift up and down only will change your y values. It's very literal. Think about it. If I take some point, and it's right here, and I say shift it up 7 units, now won't it be up here? You know what I mean? Up 7 more units. That only affects your y values. So that makes total sense. Now, when I say the sign stays the same, I need to explain. This does take memorization. So you're going to be asked to write our answers in 2 different ways. There's what's called the f of x answer. So I would write that in my notes. This is how we answer it. There's the f of x answer, and there's also the xy point answer. And it's just different. It's not that the math's different. It's just writing our answer is different. So let me show you something, okay? Let's look at, for example, right here. With an example, it makes a lot more sense. So I'm going to call, you don't even have to write out the equation of the original function, which is really nice. We're just calling the original function f of x. So if you look at the red arrows, we know blue goes to green. So we're going to call our blue function our f of x function. This means this is what we're starting with. What was the shift in words that happened? It went... Yep, up vertically 4. So we could just say a shift of up 4 units. Now, I've already written that in. We went up 4 units. Now, let me show you, if they said to you, write the f of x answer. So if they said to you, what's the transformation? Then you could write it in words. This is in words. Words is up 4 units. Then there's the f of x answer. This is what I would kind of write in my notes. So a shift of up 4 units looks like this. You'd say I'm taking my f of x and I'm adding 4 to it. So we're adding 4 on the outside after the f of x. That's how a shift up and down works. Now that takes memorization. Shifts up and down. And when I said the sign stays the same, it's because shifts up and down, you go with exactly what you see. Do you guys see from here to here, we are literally going up 4, yes? So we go plus 4. Now, let me show you the one that's unique that they actually focus in on in 1010. There's the XY answer. So what they're saying is, if we have these blue XY points, what are we now doing to the points? Are we changing our X's, my friends?
Oh.
No. So they want you to write X as X. But what are we doing to our Y values?
4.
We're adding 4, yes? So then you just write this, Y plus 4. See, that's the XY answer. We just didn't really do that in Sec 3. We just kind of did it. You know what I mean? We didn't write it like this. Yeah, it is easy, but there are some trickier ones that come up, and that's where we just need to be careful. But if you understand that, you get the picture here. So I would even like you to write down this. In general, so in general, this is how a shifted up and down is going to look. We're going to have an f of x, and then we're going to add or subtract some value, and then I would like you to write yourself a note. The sign is the same. It stays the same. So if I tell you down 7, what would it be? F of x? Minus 7. You guys see what I mean by sign stays the same? Yes? Okay. Now, once again, in general, this is how we write our x, y points. X won't change, but a shift up and down will be y plus or minus the k value. So these are the general answers. That means now you can write any equation depending on what I say. All right, awesome. So let's practice that, how they word it on the test and the homework. It says right here, explain which transformation the original blue graph has undergone to become the green graph. Now look at the instructions further. Write the new coordinates of the general x, y after the transformation. So they don't want the f of x answer, they want the x, y answer. So you once again say, okay, the blue graph, it's blue to green, yes? Blue goes to green. So you'd say the blue graph is my x, y points. What am I doing to those? I'll do it in green to stay consistent. You're plussing 10 to what?
Y.
So then you'd say x is x, but then we're taking y plus 10, and you just got a problem right on the test. Boom, there it is. Okay, good. Now, horizontal shifts. Focus, focus, because yes, that one's easy. This one has a confusing element. You've got to listen. I'm telling it so it's not confusing, but you got to listen. So shifts left and right are also considered horizontal shifts. Now think about it. If you take a graph and shift it left and right, it only affects your x values. Like if you look, like if I literally move something left and right, it's only affecting x values. Now if we're writing the f of x answer, this is only true for the f of x answer. The sign is written opposite, and fun fact for you, it's actually located inside the parentheses with the x. It looks like this, f of x plus h. Do you guys see how I'm adding it inside the parentheses? Shifts left and right are added inside the parentheses. Where's the shift up and down added? On the outside. Do you guys see the difference? This is added on the outside, and a shift left and right is added on the inside. That takes memorization. Now this sign is opposite.
So would that be going?
So if I said to you, left 7, you would say f of x plus 7. Do you see how it's opposite? Left 7, you are shifting the graph left 7. But if you're writing the f of x answer, it's x plus 7. But if I tell you, go to the graph, you need to move it left 7. Do you guys see what I'm saying? You're not going to add 7 then. So now when we're answering with our x, y answer, think about it. What would we actually do if I said left 7? I'm telling you, you go left 7. We're not going right 7, left 7. What would you do with your x's? You need to minus 7. True, everybody? So x minus 7. The y values don't change. So then people get confused. So then they say, well, Mrs. Billman, you said opposite. Not with the x, y. The x, y is a very literal translation of the verbal what I'm doing. Like left 7, we've got to actually take x's and minus 7 then. It's the f of x that takes memorization because there's unique little things in how we write it.
So the sign doesn't change for the x, y.
Exactly. Sign doesn't change for x, y, but it does change for the f of x answer. So we'll practice that. Like, let's look at this one right here. So if I said to you, the red graph goes to the blue graph, write the x answer, the x, y points, right? The blue x, y points. We'd say, okay, so red is our original graph, and what's happening? Let's write it in words. It's going, let's start with a point and go to its point on the other graph. I like this point. It's just obvious that it becomes this point. True? So verbally, let's write out what happened so then we can mathematically write our answer. What happened? It went left. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to write left 8. Then I ask myself, how do they want the answer? So I'm telling you verbally, I want the x, y point answer. So what do we do to our x's? We got to literally move them left 7. Sorry, left 8. So x minus 8. It's very literal. The x, y thing is literal. And then we're not doing anything to our y's. Everybody see? Now, once again, I'm going to change and say, give me the f of x answer. Give me the f of x answer. So this is f of x. Since we went left 8, you'd say, I've memorized that shifts left and right are inside the parentheses and we go opposite. So we do inside our parentheses. Since we're going left 8, we would say x plus 8. Because we go opposite with shifts left and right. Yes.
Why do we go opposite?
We could get into why with a line, but can we do that at the end?
Yes.
If we have time. I can show you exactly why we go opposite, though, at the end. I promise. Yes, I would love to show you. Don't let me forget.
Okay, I won't.
I don't want to blow you off.
If it's a negative, it would be a positive in the f of x.
In the
If
f
it's
of
a
x.
positive, it would be negative.
Correct, but not in the XY thing. That's why we just have to study on the test and not get that part confused. Okay, but you're right. Besides that, it's good. Do you guys need to practice one by yourselves?
No.
You're sure you got it?
Yeah.
Okay, then I won't force you to. All right, let's just do 2 shifts then to make sure we've got it for the test. So let's look at this one. So right here, if they gave you the graph and said blue becomes green, write me the XY points for green. You would say, okay, so blue is considered just general XY. Now, I've written already in verbally what we're seeing. It went up 4 and left 3. True? As you can see from the graph. Even if I didn't write that, you could figure it out. So then for green, you would say X. To get to that other side, what do we need to do?
Plus
Yep, so left 3, so we do need a minus 3 off our x's, true? To literally get to the right spot. And then we need to go up 4. So what do we do to our y's? Plus 4, boom, there it is. There's our answer. Now let's do the f of x answer. Okay, so this is where, this is literal. It's a literal translation. F of x takes memorization. I always write it in words because it helps me with this answer. So we know shifts left and right, we go opposite, and it's grouped in the parentheses. So we'd say f of x plus 3. That would be left 3. The sign is opposite. Shifts up and down, the sign stays the same. It's added on the outside. So we would then say plus 4. Boom, there's that answer. Excellent. You guys are doing so good. You got to ask questions, though. Okay. All right, I think you get the picture here. If you want to see another one, we can do another one. But if you're like, we get it, we'd rather continue onward, then let's continue onward. Over here, they want to continue onward. What do other people want? Okay, most people are saying onward. Okay, let's move on to the next transformation. Let's write this in our notes. This one does, once again, take a little bit of understanding, which will then help us memorize what to do. So we're going to now reflect over the x-axis and reflect over the y-axis. So let's talk about flipping or reflecting, flipping, reflecting, same thing, over the x-axis. I have to draw myself a visual aid every time for this so I don't mess it up. So I just do a random point. I just usually start in quadrant 1, but it doesn't matter. So I've just drawn, I would draw this in my notes. Here we go. If we were to take a point and put it right here, just randomly right here, that's some positive x, some positive y. True or false?
True.
Okay. Now I'm telling you to physically reflect that over the x-axis. That means stamp it across the x-axis. Now won't it be right here-ish? Stamp it across the x-axis. Now look at what your new xy points are. Does x actually change? No, x is still in the same location. But what happened to our y's? They're reflected. Aren't they literally the exact opposite? So they're actually getting times by -1. So I write -1 times y. Now, is it necessary to write -1 times y? No, that's me being dramatic. So you'll probably see it written like this, like in the answer of the homework. Do you see what I'm saying? Just -y. So you guys have to remember, a reflection over the x affects our y values. To fix our y values, we times them by -1. So let's now do the other one. Let's do reflection over the y-axis. Give yourself a visual aid, even if you had to do it on the test. Once again, you'd say to yourself, okay, so if I start right here at some positive x, some positive y, and I choose to stamp across now the y-axis, my new point would be like right here, wouldn't it?
Yes.
So now what's happening to my x's? They are getting times by -1. Aren't they going backwards the same distance as it was forward? So now we have -1x. -1 multiplied to x, but then the y stays the same. So notice a reflection over the y-axis actually is timesing x by -1. So that's how you fix xy points. So that's our xy answer. So under the x-axis, say xy goes to, over x, it's x -y. Yes, everybody? That's the xy transformation for reflection over the x-axis. For the y-axis, the xy answer, so you'd say xy becomes -x, positive y. Now here's where you have to memorize. The f of x answer takes memorization. So now let's do the f of x answer. So fun fact for you, over the x-axis here, sorry, I'm going to group this off. The f of x answer, if you're reflecting over the x-axis, actually has a negative on the outside in the front of the f of x. So write that down. So that's for the x-axis. This one takes memorization again. So the negative goes on the outside in front of f of x multiplied. And a reflection over the y-axis, the f of x answer is actually a negative inside with the x.
What's
Yes,
that little dot on the negative?
that's a time sign.
So it would be negative 1 times f of
Yeah,
x.
let me write that a little better. So that's just negative 1 f of x, right? We know it's times if they're right next to each other. So what's the difference? When you're reflecting over the x-axis, it would manifest like if you're doing the f of x answer on the outside. That takes memorization. If it's a reflection on the y-axis, the negative is manifested inside the parentheses next to the x. Once again, that's not hard math. We're not getting into y right now. We could later, but not right now. Right now, it takes some memorization.
So if it was reflected over the y equals x axis, it would be like negative f equals negative, like in parentheses x negative, I mean negative x.
Yeah, so you're making a good point. You're saying, like, over the y equals x axis, there'd actually be two negatives.
Yeah.
Yeah, you're right. I never even thought of that till you said that.
Did
Yes.
you say what the f parenthesis negative x parenthesis was again?
That's the reflection over the y-axis. So you just have to memorize where the negative goes. If it's on the outside, it was a reflection over the x. If it's on the inside, it's a reflection over the y. It's just a matter of where it is. Now, like I said, we're not getting into mathematically why it is right now, but we can later if we have time for that. All right, so look at this graph right here. Okay, look at this graph. So I'm going to erase some of this if you don't mind and just show you an example if no one's mad about that. Okay, how did blue become green? Write the answer as an XY point. What happened? It reflected over the x-axis. So you'd say, these are my parent function points. Green got to green by not changing x, but taking our y values and timesing them by -1. Does that make sense? Okay. Now, if you're doing the f of x answer, it's the memorization answer. You'd say a reflection over the x means we started with f of x, and now when we reflect over the x-axis, the negative is on the outside. Ding, 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 right here. Memorization. All right. So this one right here is a reflection over the, isn't it also x-axis? Yeah. Okay, so we've already done one like that. We get the picture. All right, now let's read this question. This is how they like to word it on the test. We're not going to overcomplicate it. It's a very easy problem. Read pink with me. It says a point 3, 4 lies on the graph of y equals f of x. So they're telling you that's the parent function point. If the graph is reflected across the x-axis, what happens to that point? What's our new point? You're right. 3 doesn't change, but the y value is times by -1, right, everybody? So you'd say 3, -4. Now think about it. You could give yourself a visual. Math is math. So on the test, if you wanted graphing paper, you could say, Mrs. Billman, can I get some graphing paper? You could then say, okay, math is figure outable. So it says, go over 3 up 4. That's right here. And then we need to reflect across the x. So that would be right here now, which is 3, -4. You could give yourself a visual. You know what I mean? You don't have to memorize the rule. All right, you get the picture here. All right, so right here it says, what is the graph reflected over? The y-axis. True? So the y-axis. All right, let's write our new, let's go from blue to green. The blue are our x, y points. What will happen to get to green? Yep, -x times our x is by -1 and y stays the same. Very good. Now, what if they ask for the f of x answer? This is the memorization answer. When you reflect over the y, where does the negative go? Inside. You'd say f of -x. Okay, good, good, good. All right, so right here, it's the same idea, just making sure we've got it. It says a point 1, -5 lies on the graph y equals f of x. If the graph is flipped across the y-axis, what will be the new point? It's now flipped across the y-axis. So we're at over 1 down 5. Isn't that like right here? It's reflecting across the y-axis. Won't it be right here? So what's the new point? -1. -5, right, everybody? Which makes sense. Didn't we just learn that we would times our x's by -1 when reflecting across the y-axis? Okay, good stuff. You're sure you're good, everybody? All right, moving on. All right, now right here, let's write down the word stretch and compression. So stretch and compressions, we have to get our brains to see it right now. We're only doing vertical stretch and compressions. So like, let me show you. If you were to look at this graph, some kids were saying if we go from blue to green, it's considered a compression. It's actually considered a stretch. Here's why. Vertical is this way. True, everybody? Vertical is like this. Rubber bands going like this. So if I take this graph and I go like this, it's actually being stretched vertically. If you're looking at me weird, it's because you're thinking horizontally. So once again, look, if I go like this, is a rubber band getting stretched if I go like this with this?
No.
Yes. Look, rubber band is holding this together. And now I go like this. Did the rubber band stretch? If we're going, we have to pull vertically. These are vertical stretches. So let me say that again. My hand's like this. There's rubber bands connecting it. And I pull it vertically. Now it's like this. Weren't you stretching this way? It's considered a vertical stretch. Now, is it also a horizontal shrink? Yes, but holy cow, you're confusing me. Does that make sense? Just, we're going to do vertical right now. All right, so then look at this one. If we're like this, and now we go like this outwards, didn't we compress it vertically? Yeah. The rubber band released. True? Pushed down. Okay. So this is considered a stretch for the video, and this is considered a vertical compression. And that's if blue becomes green. Blue becomes green. All right, because once again, all right, we get the picture. All right, now where is that going to manifest? Let me explain. So this is memorization. For the f of x answer, it's actually an a value. An a value multiplied in the front of f of x. I would write that down. So if you see an a value multiplied in the front of f of x, it's considered a stretch or compression based on the number. So for example, if we have 2f of x, this is a vertical stretch of 2. It's an acceleration. Now the acceleration is twice as fast. Do you guys see? Now what if I had 1/2 f of x? Now isn't it accelerating slower? So this would be considered a vertical compression. Now also, I should have highlighted this. This is very important. Vertical stretch and compressions only, I repeat, only affects our y values. That's very, very important. Vertical stretch and compressions will not change your x's. It only changes your y values. So I just showed you what it looks like with the f of x answer. I'm now going to show you what it looks like with the xy answer. X will remain the same, but you'll take your y values and you'll times them by a. That will take your y values and stretch or compress them vertically. So that's how you write the xy answer. You times a to your y values. So let's see an example so that it's less confusing, because when you see it in action, it's like, oh, now I'm seeing it better. Do you have that written down so I can erase it?
Wait,
1 second. I'm glad you spoke up. Make sure you guys speak up. I'm happy to wait. You just got to make sure you're telling me. So we have basically the f of x answer right here, the xy answer right here, and we know it affects our y values only. Okay, I'm going to zoom in on this parabola right here. So blue became green. So everybody look. If this was the blue point and it now became this point, did the x's change? No, that's what I told you would happen. What happened to the y values though? How did you get from 4 to 12? By multiplication. We times by 3. So we would answer it as follows. If they want the xy answer, you would say, okay, if I started with my blue xy's, my green got to green by x didn't change, true? But what did I do to my y values? I times them by 3. Was it 3? Yes. So that would be your xy answer. Now, if we're doing the f of x answer, if blue is f of x, I'm telling you, once again, green got there by taking 3 and multiplying it in the front of f of x. That's the f of x answer. All right, good stuff. Now looking at, I need to erase. There's too much going on here. Oh, that was an eraser, I thought. Erase, erase. Erase, 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 erase. Okay, look at this example. Let's see if we can do this one. If we went from blue to green, did the x's change? No. What happened to the y values? It went from 4 to 1. What did we times by? 1/4, right, everybody? 4 times 1/4 is 1, yes? So we times by 1/4. So 1/4 is what we're timesing our y values by. Isn't that a compression? So once again, if you write your xy answer, you would say x doesn't change, but my y's are times by 1/4. The f of x answer is 1/4 multiplied in front of f of x. Stretch and compressions are both just multiplied in the front. Yes.
So our compression's always less than 1.
Yeah, it's between 0 and 1. It'll always be a fraction. Now, when you say less than 1, when I used to say that, so people then assumed a negative. So, yes, you're right. It's a fraction between 0 and 1. It's a compression. Otherwise, it's a stretch. Great point. So, look at this problem right here. It says, stick with me. We're getting close here. It says a point 3, -4 lies on the graph of the parent function. If the graph is stretched by 4, what happens to that point? What's our new point? Does x change on a stretch? So you put 3. What's our new y value though? Stretched by a factor of 4. You're right. You take your y value and times it to your y value, right, everyone? So you're right. It would be 3 -16. Pretty easy stuff. Everybody good? So like same thing here. It says, look at this one. A point -2, 3 lies on the graph of f of x. The graph is compressed by 1/3. What happens to the point? You'd say -2 doesn't change, but then we're going to take our compression and times it to our y value. So don't we get 1? 1/3 times 3 is 1. Okay, good. Awesome. All right, so like with this one right here, let's write our xy answer. Blue went to green. So they even gave you this answer. So what do we know happened? It was stretched by 5. Let's write our xy answer. So you'd say x's are x's, but y's are times by 5. It's super easy. Now, could you write this? 5y? Yes, right, everybody? It's the same thing as y times 5. All right, we get the picture. All right, now let's put it all together. Write this down for me. This would have all the shifts, but it wouldn't have the reflections. I don't like to also put in the reflections because then it gets extra complicated. We're not going to have quite as complicated as having reflection. We will have reflections, but just trust me when I'm going to leave those out on this one. So for f of x, if f of x is the parent function, then this would contain a bunch of shifts. What does a multiplied in front do? It's a vertical stretch or compression, right? Can I say vertical S or C without anyone being mad? It's a vertical stretch or compression. Does that affect our x values or y values? Our y values. We times our y values by a. Yes? Isn't that what we just did 10 million times? All right, then let's review right here. What is this shift? A shift? Left and right. And we go opposite with left and right. True? That's the only one we go opposite on. That's for the f of x answer, that is. And then right here, this plus k is what type of shift? Up and down. The sign stays the same. Now, I actually want to write this in. So, with a shift left and right, doesn't that affect our x values? True? And then with a shift up and down, doesn't affect our y values. Now, notice in this case then, if that's true, this affects our y values and this affects our y values. Now, look at it. One is multiplication and one is addition. Do you guys agree that a is multiplied, where k is added? So order matters in which you apply the transformation. You are shifting y with 2 different shifts. However, what order do we go in? We would need to times our y values by a first and then add k. If you add k then times it, you're going out of order of operations. Doesn't multiplication come before addition when it's simplifying? So we got to make sure we go in the correct order. Then don't forget these reflections. So remember, a negative on the outside is a reflection over the x-axis, which affects our y values. Recall. Where a negative on the inside is a reflection over the y-axis, and that affects our x values. Just remember, multiplication has to come before addition and subtraction. All right. So now, with that in mind, let's write down now the xy with these transformations. Let's write down. So if we start with an xy and we perform a stretch, a shift left and right, a shift up and down, what would it look like? So what would we do to our x's? So we're writing the general rule like we did here. True? So remember, the x is the unique one. So if it's x plus h, what do we need to do to our x's? We need a minus h, right, everyone? Because remember, in the xy point, it's the more literal translation, okay? Then right here with our y values, if there's an a value, we would say a times y, and then after that, it's a shift up and down. Then after that, won't we add k? All right, so that's what the xy shift looks like here with more than one shift. Now, obviously, I'm leaving off the reflections because it starts to get hokey pokey if you're trying to add in all of them at once. So let's just see some examples before we get all worked up over this. Okay, over here, this is a really good example. So they said, starting with f of x is 2, 3, perform this transformation. So let's write down just the general rule. What are we going to do with our x's? Look at the transformation. What is this saying? Let's write out the word. Right 3. True, everybody? So what do we need to do with our x's? Add 3. Aren't we then going to be shifted right 3, everybody, on a graph? Right? We memorized that shifts left and right are inside the parentheses. Are we all understanding and remembering that we memorize shifts left and right are inside the parentheses? Yes? We go opposite of the sign. So verbally, isn't that right 3 units? So if you're taking a graph and actually for sure shifting it right 3, you need to take your x's and add 3 to them to move it to the right 3. All right, right here is a vertical stretch of 2. Does that go to our y's or x's? Our y's. So we need to take our y value and times it by 2. Then we're going up 7, true? That affects our y's. After we times by 2, we'll then add 7. Good. Then now let's actually do it. Look, they want to know what's 2, 3 become when we shift it with these shifts. What does 2, 3 become? So let's do it. What is x? It's not x, it's 2. So you're right. I'm going to show my work for the video. And then we would have y value is 3. See, x, y. So I'm doing 3 times 2 plus 7. So now you're right. I would say my final answer is 5. Isn't that 6 plus 7? 513 is my official new point. Okay. Good stuff. Does anyone have a question on why I did what? Anything? Okay. All right, so look at this one. Let's verbally write out what we're seeing. This is a reflection over the negative on the outside. That's a reflection over the x-axis. Does that affect our x or y values? When you reflect over the x-axis, it does the y values. True? Yep. Okay, y values. Then we have a vertical stretch of 2. Doesn't that affect our y values too? Which is nice, because guess what? We can hit 2 birds with 1 stone. We can just take our y values and times by -2, since those both affect our y values. What is this negative? A reflection over the y-axis. What do we need to do to our x's then? X values. Doesn't that affect our x values? Yeah? We memorize that? And that would mean right here, our last shift is down 1. Doesn't that affect our y values? All right, so let's write out our equation here. What do we need to do to our x values? Anything? Yep, we said right here, there's an x value shift. So what do we need to do to our x's? Times them by -1. Won't that reflect over the y-axis? Yes? Okay. Then we do comma, y. There's a couple y shifts. Oh, -2 is multiplied. That's got to come first. We're going to take our y value and we're going to times it by -2. That hits the two birds with one stone. It'll reflect and stretch. And then last but not least is down 1. So now what do we do after we times by -2? -1. All right, so then they'll ask, what's the new xy point? If it starts with 2, 3. So now let's go plug it in. We have 2 times -1. The y value is 3 times -2 minus 1. Because once again, they want to know, what does that point become? So it'll be -2, -7. All right, good stuff. Okay. All right, so how much time do we have left? Are we keeping track of time? Help me keep track of time. Oh, we're doing good. Okay, awesome. So let's just read this one right here, and then we're going to be close to being done here. So it says, the graph of a function is transformed by first compressing it to 1/4 of the original height and moving it vertically by 3 units, then horizontally 5 units. What happens to 1, 4? Let's do part A. What happens to 1, 4? So 1, 4 becomes what value? What do we need to do to our x's? Is there any x shift? Let's read it. Horizontally left by 5, yes? So what do we need to do to our x? We need to -5, right, everyone? Okay, and then our y value, it says compress it by 1/4. So what do? We times it by 1/4, and then it's going up by 3 units. So then plus 3. All right, so now let's go answer the question. It would be 1 - 5. 4 times 1/4 plus 3. So our new point is -4. Isn't that 1 plus 3? 4 times 1/4 is 4 divided by 4, which is 1. 1 plus 3 is 4. There's part A. Then our part A is part 1. You get what I'm saying. Now part B, it says, what happens to the XY point? Well, the good news is, didn't we already answer that right there? That's the general, what happened to the XY point. I like to write that before I do the point. So I've got it. I'd say, well, part B is right there. So what are your questions on that? That's how the homework gets worded, like this one. All right, awesome. Now let's just review real quick. There's nothing new on inverses. They're just saying, today, remember how we saw symmetry. So let me tell you something. We know how to find the inverse. If I have an XY point, how do we find the inverse of that point? We switch YX. Yes, everyone. Now, the only thing that they're going over on this today is when you do this, when you take a set of XY points and you and you switch them, it actually causes symmetry over the slanted line of Y equals X. So look at these graphs. It says, are these inverses? So what you're going to look for is, inverses are always a reflection over the Y equals X axis. So when I draw this slanted line, Y equals X, if you stamped it across that line, would it look the same? Fold it across the line. Would that one be an inverse? Yes, it would. Stamp it across. It would look just like it. All right, then right here, would this one be an inverse? Stamp it across that line. Yes. Would this one be an inverse? Yes. Would this one be an inverse? Yes, they all are. This was a trick question. These are all examples of inverses. Do you see how they're all reflected over the Y equals X? So that's the only new thing they wanted to give you. So what if they didn't give you these points? I did that for quickness purposes. So what if they said to you on the homework, given these points, graph the inverse? What I recommend doing is writing down the XY points you see. The point is 1, help me out, you guys are quicker at this. 1, 3? Oh, 1, 2, okay. Then the next point is 2, 4. Then the next point is 3, 6. Then the next point 4, 8. And the next point 5, 10. And then if they say graph the inverse, it's easy. You switch your XY points. You're going to graph 2, 1, 4, 2, 6, 3, 8, 4, and then 10, 5. And when you graph it, it looks like these points. I did it for quickness purposes. It's the purple points. And then how you check your answers to say, did I mess up? You're going to check, is it a perfect reflection over y equals x? Isn't it? Yes, everybody? So we're good. That's a way of checking your answer. So once again, to find an inverse, we switch the xy points. And then we can check it now because now we know that that's a perfect reflection over y equals x. See, look, if you stamp this, it matches across. Stamp this across this, it goes here. Stamp this across this, it goes here. Stamp this across this, it goes here. So do you guys see how it's a perfect reflection over that slanted line? That's the only thing that they're doing different. So I'm not going to do this one. I'm just going to verbalize it. So look, it says, use this graph to sketch the inverse. What would I do? I would write down the points and then do what with them? Flip them, right, everyone? Yes. And then I would graph it. And then I just check my answer by saying, did I mess up? Does it look like a reflection over y equals x? Are we all good? Okay. Same thing here. It says use the graph to sketch its inverse. Once again, you'd pick a couple points, maybe 5 points, write them down, switch them, graph it. All right, so that's the end of the lesson. I know it was a lot of info, but you'll know you know what you're doing or not with the homework, and then I can help you. So we only have like 10 minutes left. So we did do better than last hour, but it was still a long lesson. So I appreciate it.